Hey guys, we are in our free online coaching classes for the JAM examination, and this video will be the lecture 15 in this series. And the topic is the geological work of groundwater, and the book which I referred is The Principles of Geomorphology, William D. Thornberry, and General Geology by V. Radhakrishnan. Welcome to my channel Success Guru and myself Panchanathan, and let's get into the heading. The geological work of the groundwater. So what is the groundwater? Actually, the water precipitate as rain reaches the ocean in two ways. On the surface as stream and beneath the surface through rocks. The water that escapes seepage runs as surface flow and it channelized towards the sea. And that is what we call it as a running water or a river. And we had already made a video on this in our previous class. The water that enters into the ground accumulate and slowly find its way towards the ocean. The water in its hydrological cycle enter and leave the ground receiving the name groundwater. So whatever the water that enters into the ground and travels in it and that gets out of the ground will come under this heading, that is the groundwater. The groundwater is available up to 750 meters from the surface of the earth, below which it decreases in amount. The reason is that the rocks are well compacted and by pressure due to the overburden. That leads to the reduction of the pore size, and that also directly controls or reduces the water quantity on that area, on that region. The origin of groundwater. Actually, water that has not so far taken a part in hydrological cycle may come from the magmatic source. The water added to the underground storage through the magmatic emanation is called as the juvenile water. The juvenile water is the water that enters into the hydrological cycle for the first time. That is also sometimes called as a new water. The certain amount of water has been locked up in the process like rock formation, say diagenesis and lithification, but it may be released now to join the groundwater. The water thus trapped for a longer period of time in the layers of sedimentary rock and released later due to some other process is known as the connate water. The connate water is also known as the fossil water. But a large proportion of water is from atmospheric precipitation, and such a water is derived from the atmosphere is called as the meteoric water. So the groundwater originates in three different ways. One is the juvenile water, which is from the magmatic emanation, that is also a new water. The connate water, that is water that is trapped in the sediment during its diagenesis liquefaction process, that is also called as the fossil water. And thirdly, that is the majority amount of water that is reaching the groundwater is the meteoric water, that is sometimes referred as rain or precipitation. So the movement of groundwater. The groundwater actually moves very slowly through pore spaces or other openings in a rock. The movement of groundwater is measured in meters or centimeter per day, although the rate of tens of meters per day have been measured. And the average rate of say 12 to 50 meters per day is considered as a high. So the storage and movement requires the opening in a rock. So the opening space contained in a rock are fundamentally important because of the groundwater occurrence in them and move through them. The opening in a rock are of two types. The first one is the primary opening and the secondary opening. The primary opening are those which exist when the rock was formed. The intergranular pore in a sedimentary rock and the gas cavities in lava are the example of the primary opening. Whereas the secondary opening are those which develop after the formation of rock. For example, joints, fractures, solution channels along the or belong to this category. The secondary opening are found in most of the igneous and metamorphic rock and also some of the sedimentary rocks. And the secondary opening or the primary importance in igneous and metamorphic rock as it doesn't have much pore spaces as primary opening. The porosity, that is the first term that is we are introducing, the quantity of groundwater that can be stored in a rock depending on its porosity. So let us define the term porosity. The porosity is a measure of pore space in a rock, and it is defined as the percentage of pore space existing in a given volume of rock. So the porosity can be mathematically expressed as porosity is equal to volume of voids by total volume of the rock into 100. That may give the actual mathematical explanation for the porosity. The rocks vary widely in porosity. The loose sand and gravel may have a porosity up to 50%, whereas sandstone may have up to 15%, while the porosity of igneous rock may be in a range of say 2 to 3%. The next term is the permeability, that is the ability to transmit water through a rock, which can be termed as the permeability. It is the measure of quantity of water passing through a unit cross section of an aquifer in a unit time under 100% hydraulic gradient. The permeability in which the full depth and the unit width of an aquifer is considered can be termed as the transmissibility. So both are sometimes referred in synonyms, but mathematically they are totally different. All pore space are not equally permeable. For example, the permeability is closely related to the size of the pore space and the degree to which they are interconnected. If the pores are small and the rock will transmit water very slowly, and if they are larger and interconnected, the rock will transmit water readily. Clay have a high porosity, but they yield little or no water. The reason is that the opening in the clay are very small and the water in them is held by the molecular attraction, and therefore it is not free to move. So here is the guy who had measured the movement speed, and he expressed the factors that controls the movement of water, and he is Mr. Darcy. From the observation of height of water level in a well, Darcy describes the relationship among the instantaneous rate of discharge through porous medium and pressure drop at a distance. Darcy's law can be expressed as Q is equal to Ka dH by dl, where Q is the rate of water flow and K is the hydraulic conductivity, which is also called as the permeability, and A is the column of cross section through which the water is passing, and dH by dl is the hydraulic gradient. And we had actually used this formula to solve the sum, which is from GATE 2020 part B, and the question number is 23, and we had solved the sum in our numerical problem video series. If you want, you just try this sum with this formula given above and just cross check your answer in that video, that is in the link. So let us see the geological aspect of the groundwater. As other geological agents, groundwater also modifies the earth's surface through its capacity to erode, transport and deposit. The geological aspects have been described below. So let us see one after the other. The first one is the erosion. The erosion by groundwater. The groundwater carries on erosion through solution activity. So we had discussed about the running water, where the erosion has been explained earlier by saltation, suspension, traction, all sorts of things. Here the groundwater erosion is carried through the solution activity. The slow movement of water promotes solution activity. The slower the movement, that is longer the residence time of the groundwater in a region, and actually it increases the solution effect of the groundwater. Most soluble rocks are the rock salts and gypsum, but widespread are the limestone. So the corrosive water passes through the joints and fissures of the limestone and enlarges them by dissolution. The caverns which passage running say 240 km of length of USA are spectacular evidence of the slow but steady solution activity. So that shows the power of groundwater. The left side image shows the Mammoth Cave, which is in the central Kentucky city, which is one of the world's largest cave, which is having a length of say 240 km. However, the rate of solution is higher with the water containing CO2. So when the water has containing CO2 with it, the dissolving power increases, but it also decreases with increasing dissolved content. So when the dissolved content is increased, the dissolving power of the water is reduced. The limestone is essentially calcium carbonate and react as CaCO3 plus H2O, that is water gives CaCO2 CaHCO3 twice. So let us see the erosional features. All erosional features are concentrated to limestone terrain, that is more widespread and can be eroded by the groundwater. The resulting topography with a shallow depression and shallow mound is termed as the karst topography. and that is after the area cast in Yugoslavia. It is named after the area that is cast in Yugoslavia. The word cast means bare, stony ground. The karst topography includes several erosional forms, but one or more features may be found in one area, may not be found in other area. The absence of the surface stream is the characteristic of the karst topography, which you can expect everywhere. That is, if there is a karst topography, you may not see running water on the surface. The river may be disappeared on the surface. The karst topography may develop when the required points are: the first one, the soluble rock, that is essentially the limestone. The limestone bed is thin and well jointed, and there is a valley adjoining an upland, and there is an adequate rainfall. So these are the four requirements for the formation of karst topography. The following is an attempt to classify various forms as a result of groundwater solution activity. The first one is the Terrarosa. Descending groundwater actually dissolves surface and near surface material that covers the underlying rocks. The soluble materials are carried away. The residue or leached red clay soil mask the rock surface is termed as the Terrarosa, and it is found on a moderate to gentle slope, and its thickness varies from less than a meter to few meters. The left side image shows a Terrarosa. The second one is the limestone pavement. These are the features of well-jointed limestone, now exposed in the roughly rectangular pattern. Under the soil cover, seeping groundwater dissolves the limestone along the joints, and it results in the development of roughly rectangular blocks. Later on, removal of the soil cover through erosion, blocks are exposed and are known as the limestone pavements, or sometimes called as the lapis surface. These pavements are also known as the clins. Clins are found with the interlocking grix. The grix we will discuss in the later on slides. The enlarged joints, the large clins measure about 1 meter across. So the left side image shows the limestone pavements, or what you call the lapis surface, or even the clins. The next one is the natural arch. A natural arch is produced when the roof of a natural tunnel is collapsed, leaving a small bridge-like feature. And this is also known as the crossed bridge. The next one is the resurgence. That is, when a surface stream flows at a higher elevation, enters into a shallow hole and takes an underground route. At the lower elevation, it emerges as the surface stream, and this is called as the resurgence. The left side image shows there is a shallow hole where the surface stream enters, as it is a limestone region. There are caves through which the water is passing. There is no any surface evidence for this stream, and all of a sudden in a lower elevation, when there is no limestone region, this water is emerging, and that is called as the resurgence. The tower karst or the cone karst. These refers to the special type of karst topography in a flat plain. Isolated hills stands as remnants of solution activity. The topography of such a hill-studded plain is known as the tower karst. They are found in humid tropical countries. Pronounced solution activity is noticed in this undercutting of this tower hills. Cone karst is also similar topography found in the tropical region where well-joined limestone occurs. The limestone peaks and floors provide a landscape similar to an egg basket. Such a topography is known as the cone karst or cockpit karst. So this is the image, right side image shows the cone karst or the cockpit karst. The next one is the sinkholes. The sinkholes are the swallow holes solution activity. In the karst region, sinkholes are many in numbers. In some of the sinkholes, stream may disappear. Sinkholes are of two types. The first one is the solution sinkhole. The second one is the collapse sinkhole. The sinkholes developed mainly by solution activity and are called as the dolins. Dolins are shallow basin produced by the solution activity. They are say 2 to 100 meter deep and 100 to 1000 meter across width. The sides are rocky or covered vegetation. The concentration of joints may be the site for dolin development. Dolins are common features of a mature stage of karst cycle. The clogged dolins impound water, forming sinkhole ponds or karst lakes. The removal of basement causes the subsidence of the roof, and as a result of a depression on the surface is produced, and it is known as the collapse sinkhole. It has a steep side rocky boundary. The swallow holes are the surface holes leading to a sinkhole through which the water reaches the underground. The expanding sinkhole collapses to form compound sinkholes. The sinkholes are thousands in number in a karst region. The next one is the karst window. It is a special type of collapse sinkhole whose opening varies from a small to larger one. In this, it describes an exposed underground drainage which emerges from one cave and enters into the other cave. So you can see here this is a karst window, and this is a cave from which groundwater, actually running water enters, and here is a channel or a cave through which the groundwater or running water exits. So this window shows the underground movement of the water, and that is called as the karst window. The sinking creek or smaller stream whose water is lost in the sinkhole, that is called as the sinking creek. The grades are the one which we had talked about earlier, but we are explaining it here. The grades are the enlarged joint through solution activity in a grooves called the grades. So when a joint has been enlarged with the solution activity, and that forms the grades, and which are say 0.5 meter deep. Cairns is a term that is described both grades and other solution channels. That is the generalized term. The next one is the tunnel. A natural tunnel are also found in some of the limestone region. They are formed as a result of a subterranean stream piracy. As you know, the stream piracy, that is the catchment of a river by other river, and that leads to a barren valley. And here in the underground water, the same thing happens, and that leads to the formation of a tunnel. The dry valley. The streamless valley are known as the dry valley. These valleys become dry as water finds underground route, and they are supposed to have formed in a period of abundance of supply of water which flows over the limestone area and carved these valleys. The last one is the caves, where caves or caverns are the spectacular erosional feature developed by the groundwater. Caves with 2 or more levels and a network of passageways are common. Mammoth Cave of USA is an example of such an elaborate cave system that we had seen in the first slide itself. The image shows the Mammoth Cave, which is the world's longest cave. The small cave system shows clearly they are the largely an enlargement of a 3-dimensional joint system in a limestone. So if there is a joint system in a limestone, and when the water passes through it, and that enlarges the joint system, and that forms the caves, and that is how it is formed. And let us see some of the examples in the cave system, caves in India. And we had already make a 60 seconds fact in a Reed Flute Cave, which is also a limestone, cave formed by the groundwater. Although caves of India have not been studied in detail, a few of them have been survived for their fossil content. Important among them is the limestone cavern located close to the Banganapalli, that is Kurnool district of Andhra Pradesh, that is called as the Bilam cave, which is the second largest cave in the world. And this has been formed at the time of say Pleistocene. There are several caves of different dimension occur in vicinity to the Srinagar and Kashmir. And also there are hundreds of caves distributed throughout the country, which may have to be surveyed later on. The blind valleys. Actually, a valley with a dead end in the downstream direction of a disappearing stream is known as the blind valley. Initially, a surface stream may disappear in a sinkhole. However, the stream may continue its headward erosion. That net result in a blind valley. The polge. A polge is a flat floor on a karst depression with a steep walls. The origin is attributed to a faulting and or erosion. The polges are typically a Yugoslavian feature whose alluvial cover supports the agriculture, and during heavy flood season they forms a temporary lake. The ponors. The ponors are a swallow holes at the end of an polge where actually the stream disappears. The estavellan are the features that is differ in function according to the availability of water. During the winter, what happens? They act as a spring, that supplies water to the surface, and during the summer that act as a swallow hole which actually get water from the surface. talus or the polges of cold country, they are flat plains surrounded by a gentle slope hill. Whereas in polges, you may expect a steep sided wall, and here the walls are gentle, that is the surrounding area is gentle. Uvalas. Uvalas are a linear depression formed as a result of a collapse of a roof of an underground water course. Sometimes they reflect as a small part of a drainage pattern. So the right side image shows the image that is a uvala. So let us see the method of transportation. Actually, the soluble matter are dissolved in groundwater and carried in solution. The groundwater movement in limestone occurs in three routes. The first one is the percolation, that is the vertical movement of water from top to bottom. The second one is the underground drainage. When there is caves or caverns, the water runs freely and that forms the underground drainage. And third one is the movement that is below the groundwater table, which is actually very slow. So we'll see the depositional features of the groundwater after a short break.
Having trouble in understanding geology concept? Looking for one-to-one virtual class environment? Then you are in the right place. GeologyAssignmentSupport.com is here to help you in your studies. We have an expert team in all branches of geology, with doctorate and 8+ years of teaching experience. We are ready to help you in your studies. For more details, check our website. Link is in the description.
The deposition by the groundwater. The groundwater the deposit is initiated when the groundwater loses its dissolving carbon dioxide through evaporation. The solution reaction of the groundwater is a reversible reaction. When groundwater loses its dissolving capacity by way of losing the carbon dioxide, the dissolved mineral matter is redeposited. Loose sediments are cemented together to form a sedimentary rock by the deposition of the dissolved materials like say calcite, iron or silicate that we had discussed in the sedimentary class. However, the work of groundwater as a depositional agent is well illustrated in the deposit of cave and cavities. The deposits of dissolved mineral matter takes place in zone of aeration, that is just above the water table, in caves and cavities aided by the evaporation. So in some of the wet caves where humidity is high, the evaporation is insignificant. In such a case, carbon dioxide diffuses out, which causes the deposition of calcium carbonate. So the two main reason for the deposition is one, the evaporation, and the second one is the diffusion of carbon dioxide. The deposition made by the groundwater are calcium carbonate in composition and are just commonly called as the travertine. These travertine deposits may be formed chemically or biochemically. A few travertine deposits have been result as an calcium algal activity, calcareous algal activity. So let us see one after the other. First one is the helicides. The helicides are formed on the cave ceilings. They grow in all directions and they are varying in size and shape. Apparently, the growth of helicides seems against the gravity, and this may be due to the limitation of limited water supply. When the crystallization takes place, the helicides grow according to the orientation of the crystal axis, and thus that is the different part of the helicide grow in different direction. The drip curtain. The drip curtain are the curtain-like deposits hanging from the ceiling from the percolation of water through a fracture. So this image shows the drip curtain. The next one is the stalactites. The stalactites are the travertine cave deposits hanging down from the ceiling. So this is a stalactites. You can see here number of stalactites here. They acquire their icy-like form as water dripping down from an overhanging rock. As drops of water continue to fall, calcium carbonate accumulates slowly and grow downwards, and this is affected by the loss of carbon dioxide through diffusion, sometimes aided by the evaporation. Thus the precipitate attached to the roof as a ring around the vent. Successively formed rings are adhered to earlier formed one, and this tube-like one may sometimes be filled. So the stalactites may be a hollow cylinder, but they sometimes may be filled. The next one is the stalagmite. The stalagmites are also formed by the dripping of groundwater. Unlike stalactites, they grow upward from the cave floor. Drop falling from the tip of the stalactite deposit remaining matter on the floor. The stalagmites are ground counterpart of the stalactites, and the stalagmites are actually a solid column, whereas the stalactites were a hollow cones. The columns or pillars are developed when growing stalactite and stalagmite unite together. So this image shows the columns, and here is the stalactites, and these are the stalagmites. The travertine terraces. The travertine terraces are developed when pools or springs of groundwater overflows on the surface and that deposits the calcium carbonate on the surface, and that results in the travertine terraces. I think this is sufficient for that heading. If you still have any doubt, you can just discuss with me in the comment section. I have grouped my videos according to the category that you can check in my playlist. You can connect with us by mail, Facebook and Instagram, and these are the links. You can support us by like, share.